Welcome back to part 14 of our DIY Autonomous Mobile Robot Building series. If you have missed any of parts 1 through 13, check out the links in the description below or access the full playlist at the end of this video. Previously in part 13, using Fusion 360, we designed the mounting structure for the Arduino Uno and added a few holes in the chassis for M3 bolts to go through. Today in part 14, the chassis is really taking shape as we continue to make progress with the design and preparation for mounting the SG90 servo. Here I have switched on a section analysis through the longitudinal central plane, and we'll just adjust that to 20 millimeters away from the central plane. So let's activate battery pack rear hook 1, right click and isolate it as well. Let's turn off the section analysis, select the outer face of the battery pack rear hook and create a new sketch. We'll need to select capture position before we carry on. Press P to project and select the entire profile of the battery pack rear hook and hit OK. Unisolate battery pack rear hook 1 and hide the body shell. Press P to project and project the body of the SG90 servo using the construction line type. Now let's project the upper part of the profile of the board guard and hit OK. Here I have sketched a vertical construction line from a rear point at the top of the projected board guard part. Next, sketch a 10mm solid line parallel to the 14mm construction line and use the dimension tool to separate the 10mm line from the 14mm line by 0.2mm. Sketch an arbitrary horizontal line and give it a length of 52mm. Then use the coincident tool to align the 52mm line segment with the top end of the 10mm vertical line segment. Now let's use the fit point spline tool and sketch a curve from the right end of the 52mm line segment down to this projected point on the body that we have already designed. Unhide the body shell and turn on the section analysis as a guide. That 52mm line segment looks to be a bit too long, so let's change that dimension to 45mm. The curved line is extending through the body shell, so let's adjust that. This fit point coincides with the body shell, so let's hide the body shell. I'm not sure why I turned off the section analysis in the footage though. Right click on the fit point and select move copy, upon which vertical, horizontal and planar manipulators appear. I selected the square planar manipulator and moved the fit point in downward and leftward directions. Then we can select and move other parts of the curved line to adjust the shape. Switch on the section analysis again and unhide the body shell. I decided to shorten the 45mm horizontal line segment down to 38mm, and I reshaped the curved line by right-clicking at a desired position on the curve and using Move Copy to reshape the curve. I finalized on this shape, so let's finish sketch. Activate the main design and we can hide the body shell. The latest sketch, sketch 5, for the battery pack rear hook is not constrained, so let's right-click and edit it. Here I have completed sketching the basic profile of the battery pack rear hook, but it is still not constrained because of the curved line. So grab the dimension tool and dimension the ends of each handle on the curved line that was sketched using the fit point spline tool. I didn't change the dimensions much, just rounded the numbers a bit. Once you get the initial vertical and horizontal dimensions set, you can easily dimension the remaining handles like this. And there we can see that the curved line is black, meaning that the curved line is fully constrained. Finish sketch, select the portions of the entire profile, including the original shape, and extrude by -3.7mm. Make sure the operation is set to join before hitting OK. We have a problem with the battery pack rear hook 2 because it is an exact copy of battery pack rear hook 1. However, the design of Arduino Uno is not symmetrical, so that battery pack rear hook 2 interferes with the AC adapter jack connector. So let's make a new battery pack rear hook by first creating a new component. Label the new component battery pack rear hook 3. Select the outer face of battery pack rear hook 2 and create a new sketch. Press P to project. Select the outer face of battery pack rear hook 2 and hit OK. Finish sketch. Now let's extrude the projected shape by -3.7mm and hit OK. Now we can modify battery pack rear hook 3 without affecting battery pack rear hook 1. Activate the main design. Go down to the sketch of battery pack rear hook 3 on the browser and edit sketch. Press P to project. project. Project the top and rear end of the USB Type-B connector on the Arduino Uno and hit OK. Select the circle tool and create a new 12mm circle at a random location. Press P to project and project the upper edge of outer wall 2. Hit OK. We want to have this circle approximately tangent with the upper edge of outer wall 2. I right-clicked on the circle and selected Move Copy and move the circle so it becomes approximately tangent to the upper edge of outer wall 2. Next, grab a dimension tool and add a vertical dimension from the straight edge and set the vertical dimension to 0.9mm. And there we can see the circle is constrained. Let's just sketch a little construction line down to the straight edge. Sketch a 3mm diameter circle at the center of the 12mm diameter circle. Press P to project. Hide battery pack rear hook 2 so that we can project the profile of the SG90 servo and hit OK. Grab the circle tool and sketch an 8mm circle centered at the lower outer corner of the projected mount of the SG90. Select the line tool and sketch a line close to the two circles. Make the line tangent to each circle and the respective ends of the line coincident with the respective circles. Next, sketch a straight line from a rear point of the upper straight edge to an arbitrary position. Make this line tangent to the 8mm diameter circle and make the end point of the straight line coincident with the 8mm circle. Okay, so let's finish sketch. Now let's go back to where we extruded battery pack rear hook 3 on the timeline. Right-click on the extrude icon and select Edit Feature. Initially, we'll concentrate on the top portion and remove the remaining parts. The previously extruded portions disappear when you select them, and the new portions become part of the new body. So this is the new upper part of battery pack rear hook 3, which could be renamed as SG90 support wall, I suppose, but I just left it as it was. Hit OK. For better visibility, let's color this component white by pressing A and dragging a white pigment onto it. Now we can go back to the sketch of battery pack rear hook 3 and edit it. I'll just adjust the vertical position of the 12mm circle from 0.9mm to 3mm and finish sketch. It looks as though the 3mm diameter hole has disappeared, so let's edit the extrude feature from the timeline again and select inside the 3mm diameter hole, which automatically extrudes the hole. Hide the sketch to see how it looks. Unhide the sketch for battery pack rear hook 3, edit the sketch, press P to project, project the entire profile of the inner wall and hit OK. Grab the line tool and sketch a vertical line from this projected point. Then sketch a line segment at an arbitrary angle below the semicircle at the end of the slot. Make the line segment tangent to the semicircle and then make the end of the line segment coincident with the semicircle. Finish sketch. Now let's go back to the timeline and edit the extrude feature again and select the portions we'll need for the battery pack rear hook. Hide the sketch for battery pack rear hook 3, press A for appearance, and I applied a black pigment onto each part of battery pack rear hook 3 and also battery pack rear hook 1. It's probably a good idea to increase the area here to give a little more strength. So let's edit sketch 5 of battery pack rear hook 1 and modify this dimension from 52mm to 47mm. Using measure from inspect, we can find out the shortest distance from the inner corner to the outer profile, and we get a distance of approximately 11.7mm, which should be fine. Finish sketch and hide sketch 5. Now we go to the front view of the design, hide the circuit board or the perf board, go to the board guard on the browser and activate the board guard. Select the entire front face of the board guard and create a new sketch. Press P to project and project the front ends of the protrusions of battery pack rear hooks 1 and 3. Select the circle tool and sketch a 5.8mm circle at each upper corner of the two projected rectangles. Sketch a horizontal line slightly above one set of the two circles. Use the tangent tool to make this line segment tangent to the two circles, and use the coincident tool to make each end coincident with each circle. Do the same to the set of two circles on the right side as well. Select the line tool again and sketch a vertical line next to one of the circles. Before we carry on, we should project the entire profile of the board guard. Now grab the tangent tool and make the vertical line segment tangent to the neighboring circle, and then use the incident tool to make the upper end of the vertical line segment coincident with the circle. You might not need to use the tangent tool or the coincident tool if the vertical line naturally snaps into place and constrains itself. Now we just need to give a little clearance around each rectangle. I have already sketched out a slightly larger rectangle on the left side in the footage, so let's do the rectangle on the right side by selecting offset, selecting the right rectangle and applying an offset value of 0.2 millimeters. I decided to use the trim tool to remove part of the circles while being careful not to remove too much, otherwise the sketch would become unconstrained. Finish sketch. Then extrude by 3.7 millimeters all the portions that form each loop support to be integrated with the rest of the board guard. Activate the main design. Let's unhide the perf board circuit and also outer wall 1 and 2. And there we have each battery pack rear hook inserted into the board guard, with battery pack rear hook 3 now comprising of 2 separate bodies. Here I have done a sketch analysis through the board guard. As you can see, the left and right top support portions are actually penetrating through the body shell a little, so we'll need to fix that. Let's hide the outer walls again for visibility. Select sketch 5 of battery pack rear hook 1 and edit the sketch. Now if I move the protrusion down a bit, the corresponding loop support on the board guard also should adjust itself downward. So change this vertical dimension from 10 millimeters to 12 millimeters, which moves the protrusion down by 2 millimeters. Then use the line tool to sketch a slope that starts from the top portion of a vertical extension of a projected point of the SG90 servo mount down to a position 2 millimeters above the top of the protrusion. Finish sketch and extrude by 3.7 millimeters to remove the excess portion. Here we can see that the height of the loop support on the right is lower than the loop support on the left. Do the same to battery pack rear hook 3 on the other side. I used the measure tool to measure the distance between the underside of each mount of the SG90 servo and the top of each battery pack rear hook, and we get a vertical distance of 6.321 millimeters. We might make a slight positional adjustment for the SG90 servo, so select the SG90 in the browser and select the Move Copy tool. Change the move type to Free Move and move the SG90 upward by 0.021 millimeters so that the distance between the underside of each mount and the top of each battery pack rear hook becomes 6.3 millimeters. As you can see, the bottom of the SG90 is very close to the IC socket on the Arduino, but it does not overlap. I ended up moving the SG90 servo up by a further 0.2 millimeters. Here's a longitudinal section view. As you can see, the design around the neck region needs a bit of work, but we'll attend to that matter later. I decided to enlarge the upper portion of battery pack rear hook 3 to facilitate the mounting of the SG90. So edit the sketch, and the first thing we'll do is delete the constraint by which the center of the 8mm diameter circle is constrained. Let's also delete this inclined line segment by right-clicking and deleting it. Since the 8mm diameter circle is not constrained, we can easily drag it back like this. Now select the line tool and sketch a vertical construction line from the center of the larger 12mm diameter circle up to the projected battery pack rear hook upper edge. Next, use the incident tool to make the circle incident with the end point of the vertical construction line, and then make the center of the circle coincident with the vertical construction line, thereby constraining the circle and the entire sketch. Finish sketch. Now edit the extrude feature for battery pack rear hook 3 and select the newly modified portions to extrude. Make sure the extrude operation is set to join. Also, don't forget to cut the 3mm diameter hole as well. Hit OK. Hide the sketch. I might color the upper part white just to improve visibility and confirm the shape. Well, it's just as well I did that because it looks as though I have extruded part of the projected servo as well. So I'll just edit the extrude feature again and cut off the excess portion. Hide the sketch again and hit home. I might as well color battery pack rear hook 1 white as well, and also the lower part of battery pack rear hook 3. Now let's shift to the top view so that we can start designing an SG90 base for the SG90 servo to mount onto. To continue, click here for part 15. If the link isn't showing, part 15 isn't quite ready but should be soon. Check the description for my upload schedule. Thank you for watching.